For this problem, we're just going to use a little bit of logic. So what we have is a battery of 14 volts. We have a bunch of knowns. You know that 7 volts is going across this resistor. 5 amps is going through this wire. Wire then splits off into two branches. Uh, 3 amps is going through this left branch, and 2 volts is across the resistor in the right branch. And for the current and the charges coming back towards the battery, we don't know the current going through this resistor nor the voltage across the resistor. So we have four unknowns. We got I3, I4, V2, and V4. We're going to go ahead and start with I3 and just use a little bit of logic to find out what's going through. By conservation of charge and thus conservation of current, since we see that there is 5 amps going through this main wire, 5 amps then splits off into two branches. We also know that 3 amps goes through this branch. It's logical to guess that 2 amps must go through this branch. So I3 is just going to be I1 minus I2, which is this 5 amps, and this is 3 amps. So the resulting amperage or current going through this right branch will then be 2 amps. For I4, we're going to use that same sort of logic. We see that 5 amps is going through this main line, it gets split off into two branches, and then rejoins back into this other main line to go back to the battery. So the I4 has to be the same as I1, it has to be 5 amps. And that's going to be I3 and I4. Now let's go ahead and look at the voltages. One thing you got to know is that the voltage at any 2 points is going to be the same across whatever these 2 points break up into, right? So if you have a sort of a break between these 2 points, it breaks up into two branches and then rejoins back here. If you know that 2 volts goes across these 2 points here on the right branch, then you got to know that the same 2 volts is going to have to go across the left branch as well. So just by that knowledge, you'll see that V2 has to equal to V3, which is 2 volts, and thusly this follows. And lastly, for V4, the voltage has to be a voltage across these two leads, for example, has to be 14 volts. So that goes within the battery and without the battery. So the voltage across all resistances that interrupt the circuit have to be up to 14 volts. Since we know the voltage across this resistor is 7 volts, the voltage across this here set of branches is 2 volts. So it's 2 volts here and 2 volts there. So it's 2 volts entirely. And the voltage here has to be 14. Then this voltage here, or the potential difference across this resistor, has to be 14 minus the voltage drop here minus the voltage drop here. So we're going to say that V4 is equal to V total minus V1 minus V2 or V3, you could say. So V2 slash V3, it's the same. This is 14 volts. This is 7 volts. And V2 or V3, doesn't matter, is 2 volts. So this ends up being 14 minus 7 minus 2 is 5 volts. So now we have the two currents and we have the two voltages that are unknown. And this came from just using two pieces of logic. One, conservation of current, that no matter where the current goes, it has to be conserved. Nothing can get created or destroyed. So the total current going into a branch has to equal to the total current throughout all branches. And a total current from all the branches coming into a main branch has to be conserved as well. We also used the fact that voltages across 2 points has to be consistent through all branches that divide the 2 points.